Okay, let's see, connecting. All right. Hey, that's fancy. All right, let's see if it works, shall we? So, scale 6. Scale 6 is all about solving radical equations. And then we're going to be dealing with square roots and other indexes, of course. Keep in mind, I'm giving you 5 variations today. They're not all of the variations that you'll see, but more often than not, you'll be able to relate one of the problems that you do in your homework or on a review with the 5 that we see up here, okay? So let's take a look at A. We've got the square root of x, pardon me, plus 4 plus 6 is equal to 7. Well, our variable is underneath the square root. So our first step should be to isolate that radical, similar to when we had absolute value equations. And remember, the x was inside the absolute value bars. Before we could do anything, we had to isolate the term with the variable. Same thing here. So let's subtract 6 to both sides. That leaves us with the square root of x plus 4 is equal to 1. Okay, now for the square root, it's an even index. So we know that our answer must always be what? Not even, but positive. I go back and forth with the 2 also. It must always be positive. So if we subtracted and this was a -1, could we solve? Can the square root of a radicand ever equal a negative? It cannot. So in this situation, we wouldn't be able to solve. We would just say no solution. We have to now be very conscious of what the equation is stating. Is it even possible to solve? Thankfully, it was not a negative, so we can go ahead and continue solving, okay? In order for us to solve for x, though, we have to get it out of that square root. So what is the inverse operation of a square root? Squaring, absolutely. Let's go ahead and square both sides. Remembering that if we square one side, we must also square the other. So we get x plus 4 is equal to 1. Our final step is to subtract 4, so x is -3. Or is it? Dun, dun, dun. Because we have an even index, everyone, we need to check our answer. We need to make sure that the solution we found does not make the radicand negative, because we can't take the even index, the even root of a negative number. We need to check that the radicand stays positive. So if we, check. If we substitute -3 in for x, is our radicand positive? It is. And again, we're just checking to make sure that the radicand is positive. It is, so we know that this is a solution. Okay, again, for the even roots, you need to check your solution to make sure that the radicand is not negative. Everybody all right with that? Yeah? Madison, you good? Okay, Selena, I can't see you. So put in the text, or in the text, text me. Put in the chat if you have a question, please. All right, let's move on to B, shall we? Ooh. We see a fractional exponent. Are we scared? Maybe. But no, because we know that regardless of our comfort level, 1/3 can be rewritten in a radical form. What's the index? 3. So let's say we're not 100% comfortable with the rational exponents. Let's go ahead and rewrite it into radical form. We have the cube root of the quantity 6x plus 9 raised to the first power. The first power isn't going to change anything, but for the purpose of our getting used to going back and forth between rational exponent and radical form, I am going to write it out for us. And then -5 is equal to -2. Alrighty, very similar now to our previous example. Let's isolate the radical. I'm going to go ahead and add 5 to both sides. So we get the cube root of 6x plus 9 is equal to 3. At this point, we don't need to check that we can solve, like I mentioned with the previous example. Why do we not need to check here? Cami? Because it's an odd index, absolutely. All right, so if it's an odd index, in this case, a cube root, what is the inverse operation of a cube root? Charlotte? Yeah, let's cube both sides. Nice job. I'm going to go ahead and raise both sides to the third power. That way our cube root and our cube will cancel each other out, leaving us with 6x plus 9 equal to what? What's 3 cubed? 27. Well done, everyone. And now we just have a linear equation. Let's solve for x. I'm going to subtract 9 to both sides. So we get 6x is equal to 18. And then if we divide by 6, we get x is equal to 3. Now, do we need to check our answer here? Well, back up. If you're not really comfortable with your arithmetic, you're like, oh yeah, maybe I made a mistake. You can always substitute in x to the original and to the given and make sure that it is correct. But since we have an odd index, we don't need to check. We could have a positive or a negative radicand. Everybody in the class okay with that one? Yeah? Madison? Okay, fantastic. Let's move on to C, everybody. Oh, wait a second. Well, all right, it's a little bit strange. It doesn't look like anything we've seen yet, but I do see a radical, and I know that Mrs. Patterson keeps harping on the fact that I need to isolate the radical. So let's isolate the radical by subtracting 3 to both sides. We get the square root of 5x minus 1 is equal to x minus 3. I'm still a little iffy because there's 2 x's, one under the square root and one on the outside. But I'm going to keep going with what we know so far. So how can we get rid of that radical, everyone? How do I get rid of a square root? Square both sides. Excellent. Really important that you square both sides, not just one. It is an equation. Now, on the left-hand side, our radical will cancel with its inverse. So we're left with 5x minus 1. But on the right-hand side, we have a quantity that's being squared. Please, I beg of everyone listening right now, do not square the individual terms. Oh, so often we just want to. We're like, oh, x squared minus 9. And as fun as that would be, that is not at all what it's asking. So please make sure, and if you need to, write this down on your notes. When you square a quantity, you're multiplying the quantity to itself. And some of you are probably thinking, yeah, you say that a lot. Well, yeah, it's because we're still making that mistake off and on, okay? So it's good to have the reminder. Go ahead and FOIL with me on the right-hand side, please. We still have 5x minus 1 equal to x squared minus 6x plus 9. All right, so a couple things to think of so far. First, we had to isolate the radical because there was a variable underneath the square root. Second, we squared both sides to get rid of the square root so we could possibly solve for x, and we had to multiply the quantity to itself. Here's the third thing we need to watch out for, and another common mistake that we make is that we now have a quadratic, but it's not just x squared. I can't isolate the variable because I have the quadratic term and a linear term. So when we find ourselves in this situation, what do we need to do in order to solve? Cami? Oh, yes. You have to set it equal to 0 in order to solve when there's an x squared and an x. if you find yourself forgetting that, take this opportunity to write that down on your notes. Here we go. I'm going to subtract 5x from both sides. So we have x squared minus 11x. And then adding 1 to both sides, we get a plus 10 on the back. So now that our quadratic's equal to 0, we could factor if it's factorable. We could use the quadratic formula. We could complete the square. What would you all like to do? Factor? Okay. Does it factor? Are there two numbers that add to a positive 10, but no, that I quit. Are there two numbers that multiply to a positive 10 that add to a negative 11? Nicolette? Positive? Ah, very good. Thank you. So we get x minus 1 times x minus 10. All right, so x is possibly a positive 1 and a positive 10. Now, in example A, we talked about how we always had to check our answers with an even index because we can't have our radicand be a negative quantity. Well, here's example number 2, where we really need to check our solutions. If you have a variable underneath the radical and outside of the radical, if there are two variables, you must always check your solutions, your possible solutions. All right, so I'll do the first one with you. In checking, I'm just going to take the positive 1 and substitute it in for all x's in the original. All right, well, 5 times 1 is 5. And then if we subtract 1, what do we get? 4, okay. Does this solution work? It does not. So 1 is not a solution. Do me a favor, check for 10. See if 10 is a solution. Substitute it into the original, please. Is 10 a solution? Yes. All right. So we have one solution here, and that's x equals 10. Now, does anybody remember, what do we call those solutions that we find through solving, but they are not true solutions to the equation? Nicolette? Nice. Very good. So we say that 1 is an extraneous solution. It's extra. Yes, we found it while solving, but it is not a true solution. All right, any questions on C? Okay, we've got two more goodness coming at you. Let's look, oh, goodness gracious. Let's look at D. All right, yet more variation. We've got two radicals with two variables, and we're going to try to solve for one of them. Now, normally I would say isolate the radical, but we have two radicals. So I think our best bet would be to try to get rid of one of them. Is everybody all right with that? We might as well try to chip away, right, as we can and see where it leads us. Well, on the right-hand side, we have a radical all by itself. So if we square both sides, could we potentially get rid of that radical? Sure. Let's square both sides since our index is 2 on the radicals. Now, on the right-hand side, the square root and the square are going to cancel, leaving us with x plus 10. On the left-hand side, they are not going to cancel. We're going to take the quantity of 2 plus the square root of x minus 6 and multiply it to itself. that radical doesn't cancel out because it's not a singular term. It's being added to 2. All right, well, let's FOIL together. Let's distribute the 2 binomials together and see what we can come up with. The first terms give us 4. The outside terms leave us with a constant times a square root. Can I multiply the constant into the radical? Is that possible? No. Remember, for skill 3, you can only multiply radicans, so the values underneath the radical, if it's the same indexed radical. And here we just have a constant times a radical. So we're going to say plus 2 times the square root of x minus 6. You simply multiply the constant times the radical. The same thing is what we're going to find for the inside terms. So we get another plus 2 times the square root of x minus 6. Now, for the last terms, we have the square root of x minus 6 times the square root of x minus 6. What do we get? X minus 6. All right. Still equal to x plus 10. Now, it's not necessarily ideal for solving yet because we still have a variable under the radical, but let's combine like terms and see where it leads us. We have a 4 and a negative 6, so we'll have negative 2 plus, there's an x. If we have 2 square roots of x minus 6s, and we add 2 more square roots of x minus 6s, what do we have? I heard it. 4 square root of x minus 6s, right? I think, if I remember correctly, this was skill 2. No, regardless. When you're adding radicals, their index and their radicand has to be the same. Here they are, so we get a plus 4 square root of x minus 6, still equal to x plus 10. All right, well, now we only have 1 radical, and I think if we isolate it, we can square both sides again to ultimately try to solve for x. So let's add 2 to both sides, leaving us with x plus 4 times the square root of x minus 6 equal to x plus 12. Just trying to isolate that second radical. If I add x to both sides, what's going to happen? Do I want to add or subtract? Yeah, thanks. If we subtract x to both sides, what's going to happen? They cancel out. All right, so then we're left with 4 times the square root of x minus 6 is equal to 12. Still trying to isolate the square root. What should we do at this point? Cami? Divide by 4. So the square root of x minus 6 is equal to 3. Nice work, everyone. What do we do from here? Now this looks very similar to example A, just 1 square root. What should we do? Yeah, let's square both sides again. Since we have a square root, let's apply the inverse. So we get the square root of x minus 6 squared, leaving us with x minus 6 is equal to 9. What is x? And since we are dealing with square roots, double check that 15 does not make your radicands negative. Are we good? All right, so x equals 15 is our solution. Not a whole lot of difference with this particular example, except that we had to then square twice to get rid of both of those radicals. Any questions so far? Yeah, Brenda. Gotcha. So question was, when do we check the answers and then when do we not have to? If you have an even index, you always want to check that your solution makes the radicand positive. If you have a variable under the radical and outside of the radical, you must always check your solutions. So like example C. Does that help? Okay, thanks for asking. Okay, let's look at our last example, and then I'm going to give you a minute to write down some reminders for yourself if you haven't already. All right, 2 times the quantity, x minus 1 raised to the 4/3 power plus 4 is equal to 36. 4/3. Well, that's going to give us a radical and an exponent. So let's isolate the quantity. Since we know the rational exponent represents a radical, let's go ahead and isolate that. I'm going to subtract 4 to both sides. So we get 2 times the quantity x minus 1 to the 4/3 is equal to 32. Now what should we do? Cami? Divide by 2, leaving us with x minus 1 raised to the 4/3 power equal to 16. All right, we've isolated the radical term. What is our index here? 3. And since the numerator is a number other than 1, there's a little bit of analysis that's going to have to occur on our part. We will either want to take the cube root of the quantity raised to the 4th power, or we're going to want to take the cube root of the quantity with the 4 exponent on the outside. Here's where the analysis matters. In order to get rid of a cube root, what are we going to have to do to both sides? What's its inverse operation? Cube it. Okay, so in order to get rid of the cube root, we're going to have to cube both sides. Okay. How do we get rid of a 4th exponent? Raising something to the 4th power. What's its inverse? The 4th root. So we are also going to have to take the 4th root of both sides. Looking at our equation, what would you prefer to do first? Cube both sides or take the 4th root? There isn't a wrong or a right answer. It's just your preference. Cami? 4th root it. Why? Yeah, since our equation equals 16, and 16 does break down evenly if we take the 4th root, that might be the better route than cubing 16. However, this is all personal preference, okay? Regardless of which one you choose, you should get the same answer. All right, so let's do the 4th root first. Again, we're taking the 4th root because it's the inverse operation of raising a base to the 4th power. Those will cancel out and we get the cube root of x minus 1 is equal to what? 2. Yay, nice job. Then go ahead and raise both sides to the 3rd power since we need to get rid of that cube root. And that is the inverse operation of a cube root. So we end up with x minus 1 is equal to what, everyone? 8. Add 1 to both sides and we get x is 9. Now, if you are unsure of your arithmetic, not feeling real strong in your self-esteem, you can absolutely check your answer. It never hurts. But this does not fall into one of our 2 checking categories, an even index or 2 variables in the equation, one under the radical and one outside. So we technically don't need to check our answer. Whew, any questions, everyone? All righty, what I'd like for you then to do, please take a minute, write some notes about solving equations containing radicals. What do you think you will need to remember when you get home and are practicing on your own? Include information of when to be aware of extraneous solutions, please.